All right, so we are continuing with this review chapter, Chapter 1a. Today is all about combining like terms and using the distributive properties. So you should all have your notes packets out. There's a little box at the top that says combining like terms and the distributive property. That's where we're going to start. So first, combining like terms. Definition number 1 is term. Term is a number, variable, or product / quotient of numbers and variables separated by plus or minus signs. Okay? So if it's like 3x, that's 3 times x, that's still one term. But if it's like 3x plus 4, the plus breaks it up into 2 terms. So terms are basically separated by plus and minus signs. Next, we have polynomials. A polynomial is a group of one or more terms. I believe this one is not filled in, so go ahead and fill this one in. All right. If you have one term, we call that a monomial. I'm just going to fill them in so you can fill them in. Okay. So have you ever heard like someone's about to fight and they're like, we're going to go mano-y-mano? No. That means one-on-one. Mono means one. So a monomial means one term. Or do you know the term like monopoly? It's when one business runs like the whole market. One. So anyway, M-O-N-O, mono means one. Binomial means 2, like a bicycle has 2 wheels. Bi, 2, okay? And then if there's 3 terms, trinomial. 3 means 2. Or 3 means 2. Tri means 3. So, like a tricycle has 3 wheels, or what's something else that has tri in it? A what? Triangle has 3 sides. A tripod, where you put your camera, has 3 legs. Okay, so tri means 3, bi means 2, mono means 1. Same thing with polynomials. Anything more than that, we just call it a polynomial. So if it has like 5 terms, you'd call it a 5-term polynomial. 7 terms would be a 7-term polynomial. Okay? More vocab. Constant is a term without a variable, so just a number. Coefficient. I feel like there's a lot of English lessons hidden in this lesson. Like cooperates when you work with someone. Coefficient is a number that works with a variable. So it's the number in front of the variable that's using multiplication. And then like terms are terms that have the same variable with the same exponents. It doesn't matter if the coefficients are the same or not. We're looking for same variable, same exponents to be like terms. All right, here's our first example. So like terms, same variable, same exponent. I always start with the largest exponent and go in descending order. So what's the largest exponent you see? 2. Yeah, x squared. So negative 4x squared. Is there anywhere else where you see an x squared? Negative 6x squared. Those can combine. We combine them by adding or subtracting the coefficients. So it's negative 4x squared minus 6x squared. Negative 10. And then you just keep the variables and exponents the same. When you're multiplying x squared and x squared, that's when you get x to the 4th. When you're combining like terms, the variables don't change. All right, what do you think is going to come next? We have 11x and negative 5x. So what's 11x minus 5x? Positive 6x. So I'll have a plus 6x. And then finally I have my constants. So positive 10 and negative 15 or minus 15. Negative 5. Good. Box it in. That's it. Any questions on like terms so far? All right, here's number 2. Careful. All right. So this one, I'll just start in the front on this one. 14x squared y to the third. So we only are interested in terms that have an x squared y to the third. Are there any of those? Yes. Right here. I don't see a number in the front. How many are there? 1. You can put a 1 there if it helps you. What is 14 plus 1? So then we have 15, x squared y to the third does not change. It just comes along for the ride. All right. And then we have x to the third, y to the second with a negative 6 as my coefficient. That's going to combine with 1, x to the third, y to the second. So what? Minus 5. Very good. Careful with your signs. That negative stays with the 6. So it's a negative 6 plus positive 1. Signs are different. You subtract the numbers, keep the sign of the larger number, so it's going to be a minus. Questions? Here is the distributive property. The distributive property says that you can multiply the outside by each term on the inside. So sometimes I'm going to show you sort of like when you would not probably use the distributive property, because sometimes after we learn order of operations and then distributive property, students aren't really sure when to use which one. If you have something like this, I would not use the distributive property on that. I would combine my like terms and multiply by 5. Okay? When we want to use the distributive property is something when, like that, where the terms inside the parentheses are not like terms. So when we do that, we do 5 times x plus 5 times 6. Well, 5 times x is 5x. 5 times 6 is 30. Okay? So again, if you see parentheses and what's inside are like terms, you don't have to use the distributive property. The reason, or the time when it's really helpful is when you have parentheses and they're not like terms. So be careful. If you would have used it on the back side, you would have got, 15 plus 40, which still would have given you 55. You'd end up with the right answer. It's just more work, I think, than you need to do. Okay? Are you ready? Here is the first real example for distributive property. What? Now, this one I am going to write out. If you don't want to write out my first step, that's fine. I just want to show people, especially with the signs, what's going on. So this is negative 3 times x. Keep the minus sign. Then we have negative 3 times 4. Negative 3 times x is negative 3x. Minus a negative becomes a plus, and 3 times 4 is 12. If you are struggling with your signs, I suggest you write it out like this. Keep this a minus, and then just multiply the numbers, then sort out your signs. Once you get good at this, you will just do that part in your head. A negative 3 times a negative 4 is a plus 12. So if you don't want to write out the red step, I'm okay with it. If you are struggling to get the answers right, especially the signs, I would write out that middle red step. Any questions? All right, here is number 4. Again, I'm going to write out a middle step here. So for this one, I have 3 halves times 6x over 1 minus 3 halves times 14 over 1. Well, here the 2 and the 6 can simplify to 1 and 3. So what's 3 times 3x? Just 9x. I'm not sure where you got the negative from. All right, and in the back I have a 2 and a 14. I'm going to make that a 1 and a 7. Keep the subtraction sign. What do I have? 21. Now, those aren't like terms, so you don't need to get common denominators or do anything wild like that, even though our fractions are gone. Make sure you don't take it a step too far. Sometimes we get a little carried away. We know they're not like terms at the beginning, but then sometimes people magically want to combine them at the end. You got to know when to stop here, okay? This is as much as we can do on this problem. What are your questions? All right, here we go. Number 5. All right, I am going to write out that middle step. So I have negative 5 times 2x squared minus negative 5 times 3. Distribute back here. So plus 7 times 3x squared minus 7 times 5x. Running out of space. Plus 7 times 2. All right, clean up my numbers, clean up my signs. Up here I have negative 10x squared. Here I have a minus negative, so a plus 15 plus 21x squared minus 35x plus 14. I will pause there for you to catch up. Did I lose anyone? Where did I lose you? Do you know where we're at on this problem? Okay. You're just lost in general? No, okay. All right. What can I do now? Is this it? No. This one does have like terms. What are they? Yes.
The negative 10x squared on wait, what? Yeah, the 20.
Very good. So negative 10x squared plus 21x squared is what?
11x squared.
I'm going to do the x's next. Is anything combined with the minus 35x? No. Okay, and then the 15, I'm going to actually underline it this. Oh, I already did that. 15 and 14 gives me what? Positive, so plus 29. Good.
Dang it, I only switched that up. I had the 35x after the
All right. Whoa.
Interesting.
All right, like any good order of operations problem, I'm going to work from the inside of the parentheses out. So I'm going to just leave the 10 with the brackets alone. I'm going to distribute the 4, and I'm going to distribute a -1. On this one, I am not going to write out that extra step just because I think we're kind of getting used to it now. So what is 4 times x? 4x. Minus, what is 4 times 1? -4. Good. Now, in the back, I did not have a number in front of the parentheses. I just had a minus sign. I filled it in with a -1 or a -1 so that when I distribute, I actually have something to multiply by. So I have -1 times x, so -1x. When I distribute a -1 to a -6, what happens? I get a +6. Still have my brackets, +3 on the end. Now, I have to distribute again. I don't really feel like distributing 10 to 4 terms, so I'm going to see if I can combine some stuff first. What is 4x minus 1x? What is -4 plus 6? +2, so +2 plus 3. Now I can distribute. So what do I get on the next line? 30x plus 20. Do I distribute the 10 to the 3? No, it's not. I think my last, that looks a little aggressive. It just goes right here, okay? The +3 is all by itself. Poor little guy.
Oh wait, I thought you could add it.
Now I can add it, yeah, but when I was distributing, I had to leave it alone. So yes, 20 plus 3 is 23. Questions? All right. I'm going to go back to writing some stuff out because this one's getting a little tricky again. So I have 1/3 times 9x over 1 plus 1/3 times 6y over 1. I am distributing a -2/5. Whoops, I'm going to make that a fraction. Times 2x over 1 plus -2/5 times 5y over 1. All right, one term at a time. So the 3 and the 9 become a what? A 1 and a 3, good. So 1 times 3x is just 3x.
Oh yeah.
All right.
Wait, what? Oh, wait,
What happens on the next one?
3 is 6.
Becomes a 1 and a 2, so plus 2y. Now, I don't think we're going to have the same luck in the back, so we just have to multiply. So minus, multiply your numerators, you get 4x. Your denominators, you get 5. And then in the back, we're going to get plus a negative, so it's going to be a minus again. But look at the 5s, right? So minus 2y. Yikes. Ideas? Just give up?
I know combining the 2 y's. The two y's.
Okay, combine the two y's. I understand what you mean. What's 2y minus 2y? 0. I do not need to write anything. Unless that's my answer, then I do need to write a 0. You can't not leave an answer. But I still have some x's, so I don't need to write plus 0y. What can I do with the x's, though?
Add them together. Wait, no.
How do I add them together? Yeah, we need to get the 3 to have a common denominator. So I'm going to put it over 1, and then I'm going to multiply top and bottom by what? 5. So I have 15x over 5 minus 4x over 5. What does that give me?
19. Negative 9x over 5.
Oh my gosh. I've heard a lot of wrong answers. What is 15 minus 4? 11. Yeah, the x comes along. The denominator does not change.
I had a plus there.
Not sure where. Yeah, okay. So, yeah, if you had a plus, I see how you get 19. What are your questions? You guys good?
No, you have to. Don't you have to have the same common denominator?
Yeah, so yes, even though the y's canceled out, the x's could still combine, and we need a common denominator, yes. All right, here is number 8. So this takes a lot of the stuff we've learned. You have to plug in a number for a variable, and then we're going to evaluate it. So we might do some distributing, we might do order of operations. I just don't know. But I'm going to rewrite it. Everywhere I see an x, I'm going to put a -2, and I'm going to use parentheses. A lot of you were skipping the parentheses stuff, and it showed. All right, so that's what my next line looks like. So I still have the -4 outside in parentheses. Now I am squaring -2, so I kept it in parentheses. Still have the -3 times -2 plus 2. Close that set. Open up another one. So minus, new set of parentheses, 3 times -2 squared plus 4 times -2. Any ideas what you want to do? Yeah, this is just basic order of operations now. I don't need to distribute because everything is going to be a like term, right? I can just use the order of operations. So order of operations tells me to go inside parentheses first and then follow the order of operations in there. So the first thing I'm going to do on both of these is square the -2. What is -2 squared? 4. All right. I am going to go through now and take care of all the multiplication and division from left to right inside the parentheses only. So I still have this -4. 4. What's a -3 times -2?
6.
Plus 6, right? Okay. Still have the minus, still have the parentheses. What's 3 times 4? 12. Plus, and then 4 times -2? -8. Good. All right, still in parentheses. So -4 out front. What is 4 plus 6 plus 2? 12. What is 12 minus 8? 4. All right, what next? -4 times 12 is what? -48. Minus 4 is what?
Oh, wait.
Negative 52, yes. They're both negative. You add them and keep the negative sign. What are your questions? There's, yes, some up there. Can we stop for a minute? Yes, we can definitely take a little break. All right, so more practice on translating into an expression. Sometimes you will need to insert parentheses into an expression. When to do this is when you have two operations back to back. That was already in your notes, right? Nope, you need to fill that in. All right, I'll give you a second. So parentheses help us keep the order of operations correct. And sometimes when we're changing from words to expressions, you need to take into account the order that things will be done. So if you write them with the parentheses, it means one thing. If you write them without, it means something in a totally different order. Will give you a totally different answer. So we're going to practice that now. Number 9, twice the sum of a number and 6. So as you're reading this, twice the sum of a number and 6, what does it want you to do first? Twice a number or the sum of 6 and a number? The sum. Yeah, they want to have twice that total sum. So if you write it without the parentheses, order of operations just tells you to do twice the number and then do the sum of 6, right? So in order to show that you have to do the sum part first, that's when we use parentheses. So if you put parentheses around the n and the 6, that shows that the sum comes first, and then you take twice that. So these kind of take a while to get the hang of. I read through these ones a lot. But this is when it happens this is a good example for this, because if you want twice the difference or twice the sum, you got to show that that sum or difference comes first, then you do twice. The cube of the difference of 5 and a number. So what am I actually cubing? The whole difference, right? So I need to subtract before I do exponents. Well, the order of operations doesn't work like that unless you use parentheses. So what do you think this one's going to look like? 5 minus n. Yes, difference goes right in the correct order. So 5 minus n or x or whatever you want to do, and then close the parentheses, and then you cube that value. Cube means to the third power. Mm-hmm. No, if it would have said like 5 less than n, that's when you switch the order. But this is the correct order on this one. Difference does not require you to switch the order. Yes, yeah, those are the ones where you change it. Triple the sum of a number squared and 4. So we want the sum of a number squared and 4, and then we want to triple that. That's how I would read this problem. So triple the sum, so do the sum first, of a number squared and 4. What about a number squared? Would you do that before the sum, after the sum?
No, that'd be
You would do this, yeah, you would square it before, actually, because it wants the sum of the number squared and 4. So that part doesn't need an extra set of parentheses. The only part that needs the parentheses is where it's tripled. So you can still square the n. Sum means add, so you can still add the 4. And then that whole thing is to the third, or not to the third, times 3. All right, today we learned what?
We learned about like terms and distributive properties.
Yes, we learned to combine like terms. And we also learned the distributive property. Now, I absolutely hate Friday homework. However, you have 18 minutes, so go ahead and get it done in class.